Hey everyone! In today's video we're going to be talking about factoring simple trinomials. This is arguably one of the most important skills in the grade 10 course. It's something that we're going to use in this unit and in future units, and it's something that you're going to use in grade 11 and in grade 12. So with that being said, it's important that you really take your time and you understand the ideas of factoring when you're dealing with trinomials, because eventually you'll be dealing with larger things down the road. Just a little bit of background before we get into the lesson and some examples. A simple trinomial has a coefficient of 1. So, for example, x squared plus 6x plus 5 is considered to be a simple trinomial because there's an invisible 1 in front of the x that we just never write. So if ever you're needing to look up help, what you're looking for is simple trinomials because there is no number in front of the x. There's no a value. Down the line, we're going to be dealing with examples where there is a coefficient for your x squared, but for right now, we're only dealing with a straight up x squared. So recall the standard form of a trinomial is ax squared plus bx plus c. And simple trinomials have an a equal to 1, right? So that a is equal to 1, therefore there's no coefficient of x squared. In order to factor a simple trinomial, we need to find two numbers. So we need to find two numbers that add to b, i.e. that add to our middle coefficient. And we need to find the same two numbers that multiply to c. And in this case, c is our solo number at the end there. This is where knowing your times tables comes in really handy. That's the fastest way to do it, is just to kind of know them. Eventually you'll get into some muscle memory and you'll be able to do this a lot faster, but for now we're just going to take it slow. Let's consider the first example here. Factor x squared plus 9x plus 18. Here I need two numbers that add to 9 and that multiply to 18. What we are going to use to keep ourselves organized is called the x method. You're basically just going to draw an x, and I'm going to say they need to multiply to the number that I have on top here. So in this case, it's 18. And they need to add to the number in the middle, which is 9. Okay? It doesn't matter where you put the times and the plus on your x here. It just matters that you're keeping yourself organized. So 18 is our c value that it needs to multiply to, and 9 is our b value. Well, our two numbers are going to be 3 and 6. 3 and 6, 3 plus 6 is 9. 3 times 6 is 18. So we have our two numbers. We are going to use a method that is called decomposition, which means that we're breaking down the problem in order to make it easier to follow. Decomposition is going to look like this. I need to split up my 9x term. I'm going to do x squared, and I'm going to leave my 18. But instead of 9x, I'm going to use 3x and 6x. I have not mathematically, algebraically, in any way, shape, or form changed the problem here. All I have done is rewritten it in a decomposition form. Okay, this strategy is going to be very helpful when dealing with all different types of factoring. From here, you are just going to common factor, or we're going to group factor, I should say. We're going to group factor the first two terms, and then we're going to group factor the second two terms. Group factoring the first two terms, I can pull out an x, which leaves me with x plus 3. Group factoring my second two terms, I can pull out a 6. And that leaves me with x plus 3. We're following in the tracks of the group factoring here. with the fact that what we have factored out, the x plus 3, is identical. And therefore, we can skip right away to x plus 3 times x plus 6. Okay, so just a little note here, we followed group factoring. And then this is our final solution. Okay, let's do another example. X squared minus 12x plus 27. We're going to go ahead and set up our x over to the side here. Multiply to 27, add to negative 12. In this case, our numbers are going to be negative 3 and negative 9. Negative 3 times negative 9 is 27. Negative 3 plus negative 9 is negative 12. Let's decompose our problem here. Now the good thing to know is that it doesn't matter what order you put your middle two terms in. At the end of the day, you are going to be able to factor it properly. I factor by grouping with my first two terms, so I'm just going to pull out an x. That leaves me with x minus 3. And here I'm going to pull out a negative 9, which leaves me with x minus 3. I can finish off my group factoring to have x minus 3, x minus 9. Now, one of the things you might have noticed in these two problems is that whatever is left in the brackets in your final form of your factored solution is the exact same as the numbers that you picked. I wanted to show you what decomposition looked like in case you ever got stuck. But if you're comfortable, you can jump straight to the solution. Let's talk about what that looks like here. X squared minus 13x minus 30. Draw my x, times and plus. We need to times to negative 30 and add to negative 13. The two numbers that do that are negative 15, positive 2. Via the decomposition method, I would go x squared minus 15x plus 2x minus 30. I would then group factor x times x minus 15 plus 2 x minus 15. I finish my group factoring x minus 15 x plus 2. I did not need to show these middle two steps. I could have just jumped straight to x minus 15 x plus 2. Let's do that in our final example here. X squared plus 11x minus 12. I'm going to draw my large X over here off to the side of my paper. I need the two numbers to multiply to negative 12 and add to 11. In this case, our numbers are going to be 12 and negative 1. So I can immediately jump to this in factored form is x plus 12, x minus 1. If you want to show all of the decomposition steps, you are more than welcome to. However, you do not need to. You can jump straight to the final answer if you're comfortable doing so. And that's that.